Today we're going to talk about factoring, and we're talking about factoring quadratic trinomials. So we're factoring polynomials in the form x squared plus bx plus c, where b and c are just representing any number that we can put there. Now, to factor something that is a quadratic trinomial of the form x squared plus bx plus c, I'm going to show you a few tricks that I use. But first, let's finish off this sentence. Essentially what we're going to do is we're going to try to find two numbers that multiply to make c and add to make b. And I've got some tricks on how to do this. But there is one other thing. If we can't find any numbers, so if no such numbers exist, then the trinomial is not factorable. So when we're talking just this format, x squared plus bx plus c, essentially what we're going to be doing, in fact, I'm going to give an actual trinomial instead of b and c. If we have something like x squared plus 9x plus 18, and then I'm going to also do the same problem, but I'm going to make it minus 9x, just so we can see the difference between the two. When we are factoring, we are trying to ask ourselves what numbers multiply, and I'm going to make a little table between these. In fact, I'm not going to do it between them. I'm going to make it here on the left side. What numbers multiply to make 18? And then we're looking for the sum of those numbers because we want to check that they make 9. So numbers that I know multiply to make 18, I've got 1 and 18. I've got 2 and 9. I also know that 3 and 6 do multiply to make 18. If I added 1 and 18, that's going to make 19, which is not 9, so that's not what we're looking for. If I added 2 and 9, they make 11, which again is not 9. I do know, though, that 3 and 6 add to make 9. So those are the numbers we're going to use. My trick that I like to use when I'm writing the factors, I'm going to put x in 2 sets of parentheses, and then I'm going to put my numbers that I know multiply to make 18 and add to make 9. They multiply to make my c term and add to make my b term. So this first group of parentheses goes to the plus 9, and then this second group of parentheses is going to go to the minus 9. My trick for knowing, am I going to put plus signs between the x and the numbers or minus signs, comes from a song that I'll play for you in class. When we have a plus sign at the back, like we do in this case, if I have plus c, the signs that are going to go in both my factors are my sign that's in the middle of the expression. So I'm going to take and put a plus sign into both of these if I have a plus 9. If I have a minus sign, I'm going to put a minus sign in both factors. So I've got some official examples I want to go over. And our first one, we'll call this example 1, our official example 1, is going to be, we're going to factor x squared plus 6x plus 8. So we want numbers that multiply to make 8, and then we're going to check what they add to make. So numbers I know that multiply to make 8, 1 and 8, and 2 and 4 multiply to make 8. If I add 1 and 8, they make 9, which is not 6. But if I add 2 and 4, that does make 6. So now I'm going to set up my factors. I'm going to have x's in both sets of parentheses. I'm going to write my 2 and my 4, and I look at the trinomial I have here. I've got a plus sign, which means both sets of parentheses are going to take plus. So my answer is going to be x plus 2 and x plus 4. Now this trick is only going to work when that last sign is a plus. Let's look at another example. We'll keep it up on this page. This will be our second example. Again, we're going to factor, but this time we're going to factor x squared plus 5x plus 6. So our goal is the numbers need to multiply to make 6, and we're trying to figure out which factors of 6 add to make 5. Well, I know numbers that multiply to make 6 are 1 and 6, and 2 and 3, and I know 1 and 6, if I add them, make 7, so that's not going to work. But 2 and 3, they add to make 5, which is what we want. So we're going to set up two factors, x's in each. We're going to put our 2 and our 3. Since this last sign is a plus and the middle sign is a plus, we're going to put a plus in both factors. X plus 2, x plus 3. Let's look at another example. Example 3. We're going to factor x squared minus 10x plus 16. Okay, now the method we've been doing is going to continue to work as long as we have a plus sign at the end, which we still do. So we want numbers that multiply to make 16, and then we're going to check what they add to make. So numbers that I know that multiply to make 16, I know 1 and 16 do that. I know 4 and 4 and 2 and 8 all multiply to make 16. I want to make sure if I add these, they make 10. 1 and 16, if I add, make 17. That doesn't work. 4 and 4, if we add them, that makes 8. That doesn't work. 2 and 8, though, if I add 2 plus 8, makes 10. That's what we want. So I'm going to set up my two factors, x in both sets of parentheses. I'm going to put my 2 and my 8. Now, the method we've been using still works. Since that's a plus sign at the end, we're going to use the sign in the middle. So this is going to be an x minus 2 and an x minus 8. Now, I haven't gone over this in the other examples, but you can check this. If you FOIL the two binomials or all the factors you get, you can check to see if you get the original problem back. Now, there's going to be some different things that happen if we have a negative at the back. For example, in our fourth one, we're going to have x squared plus 7x minus 18. If we have a negative number at the back, it's going to be interesting. What we're trying to do is find numbers that multiply to make negative 18, and they need to add to make 7. So there is one difference I made in this table. Before I was just multiplying to make a positive number, now I'm multiplying to make a negative number. So for multiplying to make a negative, remember we need a positive number and a negative number. So I know 1 and 18 multiply to make a positive 18, but a negative 18 might need one of them to be negative. So I am going to write negative 1 and 18 and 1 and negative 18. I also know that 3 or negative 3 and 6 and positive 3 and negative 6 add, or multiply, to make negative 18. I also know that negative 2 and 9 and positive 2 and negative 9 multiply to make negative 18. Now what I'm going to do is I'm going to go through this list of factors until I find which one, when I add the two numbers, gives me a positive 7. If I go negative 1 plus 18, I get 17. That's not what I want yet. Positive 1 plus negative 18, that gives me negative 17. Still not what I want. Negative 3 plus 6 gives me a positive 3. We're getting closer, but still not 7. 3 plus negative 6 makes negative 3. Still not what we want. Negative 2 plus 9 makes a, oh, look at that, positive 7. That works. Let's just check this last one to make sure it doesn't work. So 2 plus negative 9, that makes negative 7. That's not what we want. Now here's another thing when we're setting up these factors. We're still going to do 2. They're both going to start with x. I'm going to show you another little trick. We know that 2 and 9 were our factors, and we know that 2 was negative. Another little trick to this is if we have a minus sign, we want to make sure that the numbers that we're using still add to make that middle number, but one's going to be positive, one's going to be negative. The bigger of these two numbers is going to take the middle sign. So the plus sign is just going to go with the 9. Then we're going to have a minus 2. So x minus 2 times x plus 9 are the factors of x squared plus 7x minus 18. I've got one more example, and then I'm going to sum everything up for you. So example 5, we're going to factor x squared minus 5x minus 24. So one thing, because this has a minus at the end, we know our factors are going to have an x plus and an x minus. So this is just another kind of going off the trick from the last example, but we might not have to write all the factors that multiply to make negative 24 in order to check which ones add to make negative 5. So numbers that I know that make negative 24, or even just 24 in this case, 1 and 24, with one of them being negative. I know that 2 and 12, again with one of them being negative, works. I know 3 and 8, again with one being negative, and then I also know 4 and 6 can multiply to make 24. If I add together the negative 1 and 24, I'm going to get 23. And if I switched them and made the 24 negative, we'd get negative 23. Maybe you saw that in the last example. If I add negative 2 and 12, I'm going to get 10, and so far these factors don't work. And if I switch to the negative, it's going to be negative 10. Still doesn't work. Negative 3 plus 8 makes positive 5. And 5 is the middle term, but we want it to be negative. So we would just need to switch it, make it negative 8 and positive 3. But I also want to check this last one, the negative 4 and 6. If we add them, we'll get 2. And if we switch to the negative and the positive, we'd get negative 2. So that doesn't work. So the factors we know are 3 and 8. the one that goes in with the minus sign is going to be the bigger one, because in this case the middle sign was minus. So we're going to go x minus 8, x plus 3. Alright, I want to sum up real quick on everything we've done. So to sum up, there's 4 cases, in a way, we've talked about in this video. We can have a quadratic that's in the form x squared plus bx plus c. We can have, in fact, if that happens, we're going to have factors of x plus a value times x plus a value. And that happens because if we have the plus sign at the end, both factors take the middle sign. That also happens if we have x squared minus bx plus c. Our factors will be x minus something times x minus something. Because we've got a plus sign at the end, both factors take the middle sign. Now where it gets a little bit more tricky is if I have x squared plus bx, and this last number is a minus c, or if I have x squared minus bx minus c. Both of these are going to factor to something like x minus a number times x plus a number. The thing that determines, or that's different between the two, is in the first one, with the plus b, the bigger factor goes in the parentheses, or goes in the group x plus something. The smaller one goes in the group x minus something. In the other problem, if we have minus b and minus c, it's a little different. What happens is the bigger factor goes in the group x minus something, and the factor, the bigger factor, and the smaller factor goes in the group x plus something. That wraps up our intro on factoring quadratic trinomials. In our next lesson, we're going to see what happens if there's a number in front of x squared.